Today in class we are talking about the water cycle, and I want to review the biomes while you guys are getting your stuff out. So biomes we talked about and we said that they are large regions where they have a specific type of plants and animals in a specific climate. Now we said there are two things that determine what biome is in a specific area. Do you remember what those two things are? One of them is precipitation, so the amount of rain that they get. And the other one is temperature. So temperature and precipitation are the two most important things that determine which biome is located in which area of the world. If you think about it, right, how does the tundra differ from the desert? Well, they're different temperatures, okay? How does the desert differ from a tropical rainforest? They're about the same temperature, but they have different amounts of rainfall. So the water cycle should be reviewed for you guys. You should have talked about it in elementary school or in middle school, but we're just going to review it. And if you already learned it, that's great, because then hopefully this will just be easy for you and it can be free points on the test. So to begin, energy, water, nitrogen, and carbon are constantly being recycled through ecosystems. So we've been talking about food webs and how the energy moves through food webs. Well, water and other elements, nitrogen, carbon, also move through food webs and are being recycled. So we talked about how energy in food webs moves from one organism to another, and eventually, at some point, an organism dies, and their energy goes back into the environment and into the soil. Well, the same thing happens with water, nitrogen, carbon, all of those things. So something that I find really interesting, which you don't have to write this second point, don't worry about writing this, is when you drink water or you take a shower, this is the same water that the dinosaurs used. How cool is that? So water isn't created, it's not destroyed a lot of times on Earth. It doesn't just go into outer space, it sticks around. It's just recycled, purified, filtered, and it ultimately ends up being the same water that was around millions of years ago. So this picture of the water cycle should look maybe a little familiar, or some of the words should be familiar on here. So we're going to talk about each one of these. So the first thing we're going to talk about, I'm going to hide this bottom one, is evaporation. Where does evaporation occur in the water cycle? It happens from big ponds or rivers or streams or oceans or anywhere that we actually have water sitting on Earth. And this is when that liquid water turns into gas. Where does that gas go? It's water vapor. It's in the air. So evaporation happens when this liquid water heats up a little bit and then turns into water vapor. If you leave a glass of water out, say for a couple weeks, eventually the water in that cup will disappear. Where did it go? It went into the air. So this water vapor is constantly in the air around us, and this is what leads to it feeling really humid or muggy outside, because that's just water vapor. Now, another type of evaporation, this might be a new word for you, is called transpiration. This is when water evaporates from leaves of plants. So you guys know plants need water. They take in water through their roots, but some of that water is lost through little tiny holes in their leaves. Now you can't see these holes unless you look under a microscope. But these little holes are the same holes that let in carbon dioxide so that the plant can do photosynthesis. So water evaporates from the leaves, and this is really important because when it evaporates, what happens is there needs to be more water brought up from the stem to replace the water that evaporated. And so it actually pulls water from the roots and from the soil, and this is what causes plants to take up water from the soil. All right, so once we have water vapor in the air, either from plants or from puddles, streams, rivers, ponds, we get condensation. This is when water vapor turns to liquid. So the water vapor in the air turns to little liquid droplets and forms a cloud. So a cloud is actually little droplets of water that are hanging out in the air. And fog is the same thing. So if you've ever driven or walked through fog, it's the same thing. It's these bigger water droplets that are kind of suspended in the air. And we see white clouds and gray clouds and black clouds, and the darker the cloud, the more rain it has. Okay? And you guys know that. So as this cloud accumulates more and more water droplets, it turns darker. So this is the process of condensation. You may have also seen condensation on the outside of your glass on a hot day. What's happening here is the liquid in your glass is really cold. So what it does is it's cooling down the air right next to that glass, and the air that's right next to it has water vapor in it because all air has water vapor. And so when we cool down some of that water vapor, it turns from a gas to a liquid. So what you see on the outside of your glass is just that water vapor that is now turning into a liquid. It's water that used to be in the air, but now it's on the outside of your glass. So once we get lots of clouds, right, and they get heavy enough, we get precipitation. So this is rain, snow, sleet. Precipitation you've probably heard on the Weather Channel. It's just when the water gets heavy enough and then the droplets fall, either as snow, as ice, whatever. Okay, so this is precipitation. So this word should be familiar to you guys. Now, when it rains or snows, the water has two places it can go. It's going to go down to the earth, but then what happens? Well, the first place it can go is it can run off. And what happens is it'll kind of pool and then it'll run off into like a river or a stream. So this is called runoff. So it's when water drains away into lakes, rivers, and streams. If there's ever been a storm, you guys have probably seen the water rushing down the road and into the storm drains, the little grates that are in the road. That's a form of runoff. If we didn't have storm grates, it would run into a river or ocean or stream, and those storm gates actually do a lot of times run off into streams or lakes. So runoff is what we get when rain passes over the ground and then it collects somewhere. Now, this is something that's really important, and scientists are looking a lot at it because let's say you're a farmer in this field here and you just put on fertilizer. Well, if it rains, what's going to happen is all that fertilizer and chemicals is going to go with the rain into that river or stream. And then the little fishies in that river or stream, right, are going to have some of those fertilizers and chemicals in them. And then the animals that eat the fish get some of those chemicals in them. We might if we eat the fish. And so scientists are looking at how do these chemicals affect animals and humans. And we'll talk a little bit more about that in our last unit. And then we have infiltration. This is when water seeps into the ground. So instead of running across the ground, it actually drains into the ground. Now we're going to talk about how humans kind of changed this, but water can only drain into the ground if there isn't already a ton of water in the ground, or if the ground is not rock hard. Okay, so if the ground's really hard, the water can't really seep into the ground. And eventually what happens is this water drains into the ground, it goes deeper and deeper, and any of the chemicals or gross stuff that came with it, let's say it ran over, the water ran over some pavement and picked up some motor oil or a field and some chemicals, all of that gets cleaned. So you might think of dirt as dirty, but when the water goes down through the dirt, it's actually cleaning it. It gets rid of all of that gross stuff, the chemicals, the dirt, all of that, until it gets down to this thing called the water table. So we have these little pockets of water really, really deep in the ground. And this is what people use when they dig wells to get water, is they dig all the way down to the water table. And this is where the clean water is because the dirt already cleaned it as it went down. Okay, so this is called infiltration. So the last thing we're going to talk about is 2 ways that humans disrupt the water cycle. I'm going to get rid of this one for a sec. So we're talking about how do humans change this water cycle? Well, first of all, we pave a lot of stuff. Think about all the pavement we have just here at Tremper, right? Sidewalks, parking lots. I mean, even the school is on a foundation. So what does pavement do? Well, when we put pavement on the ground, all of a sudden the water can't get through the ground. It can't do the infiltration and it can't get cleaned. It ends up running off, okay? And when it runs off, what happens is there's a lot more water that runs off because it couldn't sink into the ground, and it runs off really, really quickly into streams and rivers, and it can cause a lot of flooding. So by having pavement on our land on a lot of different places, we actually can increase flooding because the water can't soak into the ground as well. And then the other thing is acid rain. So acid rain is not as common as it used to be. That's good because acid rain is not a good thing. But we've passed some regulations that have helped with this. So acid rain is formed when rain mixes with air pollution. So pollution from like factories and smokestacks like this. A lot of my students told me this looked like they call it the big smokestack or cigar in Pleasant Prairie. Well, we don't have to worry about acid rain down here as much because the United States has passed some regulations that have said we can't have this certain kind of pollution or chemicals in the air that cause acid rain. So while we still have smokestacks, they don't have the right kind of chemicals to make acid rain because it has to be a certain kind of air pollution, a certain kind of chemicals that come out of this that create acid rain. So this air pollution mixes with the water droplets in the clouds, and then it rains down, and it's acidic. It's an acid. Now people ask me, well, do you get burned from acid rain? No, you don't get burned from acid rain. It can be really detrimental to plants and animals, but as humans, we don't get burned because it's not strong enough. Think about other acids. Soda is an acid. It's acidic. Lemon juice, okay? Orange juice. If you were going to take a shower with orange juice or soda, would you get burned? Nope. So acid rain is just a weak acid. It's not the kind of acid that eats through your skin. But for a lot of plants and animals, they don't have really awesome skin like we do. Think about like fish. They have gills, so they take in water. And if this acid rain mixes with the water, it's going to affect them. Or plants. Plants don't have a skin, so a lot of times this hurts their leaves and makes it really hard for them to grow. So these are 2 ways that humans kind of alter or disrupt the water cycle, and you'll need to know both of these for the test.